if you calculate Reynolds number and you understand that this one is less than 2000, it means that your fluid has the linear shape, or it's called as the laminar one. It means that if you just consider a pipe in this way, and you have actually some arrows in this case, which are related for the shape of the flow inside of the pipe, you will understand that all these arrows are totally, parallel to each other. So you can have the calm and to some extent, your fluid is in peace or quiet things, in the pipe, and it just, passes very smoothly and very uniformly in the pipe as well. So this one would be called as the linear or laminar fluid based on the Reynolds number that you can see over there. Another one, if the Reynolds number calculated and it's, for example, between 2000 and 4000, you can get a result that this one would be called as the transient one. It means that we have actually some types of distortion, or we have some types of, turbulency, but it's not actually a high one. It's something just like that. These arrows are close to each other, or try to, for example, cut each other, or try to, interfere with each other. The previous one, here, were totally, parallel, but in this case that I'm telling you, you can just have it in this way. These arrows starts to actually close to each other, something like it. It means that we can find a type of, distortion between them. And finally, if the Reynolds number is greater or equal than 4000, you can get a result that your fluid is in turbulent situation or turbulent condition. It means that you can just have it based on the thing that I'm just drawing for you. You can see, all these arrows in this way without any, for example, regular shape, and they started to actually, attack, to the pipe, and they just rush into the pipe very fast. And as you can see here, there is no any, shape, or there is no any format for this one that you can just consider. Even in this case, these types of pulsation can be felt the time that you just touch the pipe and put your hand on the pipe. You will understand that actually, the vibration and pulsation that just, happen due to the turbulency of the fluid. I can just, make some examples for you to make this one more clear. Just imagine the velocity of the fluid just goes up. That's for sure. When the fluid, has, more velocity, for sure it's going to be, more turbulent. It's totally clear. Just imagine, for example, you have 0.1 meter per second, as the velocity of the flow or fluid actually in a pipe. The time that, for example, it just changes to 10 meter per second, that's for sure actually you have actually more turbulency in the pipe. Just imagine about the internal diameter of the pipe. You can just imagine a 2 inches pipe in your mind, and then try to compare it with the 20 inches of pipe. For sure in 20 inches, for sure actually we have more turbulency. And now you can just, make an example, or actually, imagine viscosity in your mind too. Just imagine you have oil in pipe, and actually, just it passes, through the pipe. Now you can just have honey or even tar in your pipe. For sure, due to high viscosity in the pipe, the amount of turbulence is just gonna be, less, because the more viscosity here, the less Reynolds number you have, and for sure in this case we can just reach to, for example, linear condition. So based on those examples, I wanted to just clarify what this item is and why we should just consider this one in our designing and formula or equations. You cannot imagine this one up to now. Up until that, I'm just starting to tell you the related items for the instruments, but you can just have my words in your mind that the time that we want to select or choose an instrument for our application, we have to think about Reynolds number carefully, because some of our devices are totally sensitive about changing the Reynolds number. It means that if, for example, we have turbulent fluid, we must just let it be quiet or let it be calm, and after that try to calculate or measure the amount of fluid in the pipe, while some of our other devices, which are actually totally limited, do not have any sense about related Reynolds number. So it doesn't matter whether we just pass turbulent fluid or even calm or linear fluid from them, doesn't matter at all. So do not forget, for these types of things, we have to think about Reynolds number, calculate it, and concerning this part, and after that try to select it.